Hi friends, I am Yakuta Karkhanawala. Today we are going to see the next topic of pointers, that is pointers to a pointers. Now pointers to a pointers, the other name for this is double pointers. It is also known as a double pointer. Let's understand what to understand by a pointer to a pointer. Normally we have seen that a pointer is a points to a memory location. Means we can store the address of any variable in a pointer. So we have a first pointer which will store the address of a variable. How will it be? We have a variable a whose value is 10 and it is at address of 1000. When I say first pointer is used to store the address of a variable, it means that I have a pointer P1 which will store the address of a variable A. So the A is at address 1000, so P1 will become 1000. P1 is itself stored at some memory address. Say for example it is at 2000. So our first pointer has been done. Now we have a second pointer which is going to store the address of first pointer. It means that we have a pointer P2 which is going to store the address not of a variable but of a pointer, that is P1. P1 is at address of 2000, means P2 will have the address of another pointer 2 which is equal to 2000. P2 is again located at some memory address, say for example it is at 2000. Here P1 is a simple pointer and P2 is a double pointer. Similarly, we'll see this in terms of a memory layout. We are using three variables, a pointer P1 and a double pointer P2. The value of a is equal to 10, which is stored at address of 1000. The value of P1, that is, it stores the address of a. So, what is the address of a? That is 1000 is stored in P1. P1 is itself at address 2000. P2 stores the address of pointer P1. So P1 address is 2000 which is stored in P2 and P2 is itself at address 3000. So P1 points to A and P2 points to E1. So this is known as double pointer, that is a pointer pointing to another pointer. How we are going to declare a pointer to a pointer? So for that the declaration, the syntax is data type. Since it's a double pointer, we have to put here double star and give any pointer name. Whenever we give double star, it means it's a double pointer which is going to store the address of another pointer. Let's understand this with a program. Suppose I have a variable integer x, it's a simple variable. Then I have a simple pointer, that is star of P1. And also I have a double pointer, that is P2. So since P2 is a double pointer, I'll put double star in declaration part. What it means is that P1 is a pointer which will point to a memory location which has integer value, and P2 is a pointer which is going to point to a pointer, and this pointer should indirectly point to an address which has an integer value. Now I want to store some value inside x. So for that I am using simple scanf operation for inputting some value inside x. If I want to display the address of x, it would be %u, that is for unsigned, because addresses are positive integers. Address of x means ampersand of x. So when I'll display the address of x, I'll get this value. Enter a value, and inputting the value of x is equal to 12 and the address of x is this. This is a random value that has been displayed. Whatever free memory location you have, that has been displayed here. So say for example the address of x in my case is 6422300. In your case the addresses may differ. Now what I want to do is I'll want to initialize pointer P1. So for P1, for initialization of a pointer, we'll use a normal methodology, that is storing the address of a variable. So P1 is address of x. If I want to display the value of x using the pointer P1, then I'll use star of P1, a normal method. So I'll get value printed using pointer 1 would be 12. When I'll do star P1 means P1 has address of x and x has a value of 12. So that 12 is displayed onto the screen. If I want to see what is stored inside P1. So inside P1 I am storing the address of x. So if I'll display this address stored in P1, I'll get 6422300. That is the address of x. This is the address of x that has been displayed using P1. So P1 has this address. When I do star P1 means at this address what is the value, that is 12 will be displayed. Okay. Also P1 is stored at some particular memory address. So if I want to display the address of P1, I'll use ampersand P1. So this is my address of P1. So P1 is stored at address of this. Inside P1 I have this address and inside this address I have the value of 12. So this was a normal pointer which we have seen earlier. Now I want to use the concept of double pointers. So what I'll do is I'll initialize the second pointer, that is P2. So how you're going to initialize P2? We need to store the address, but the address should be of a pointer. So P2 is equal to address of P1. Now using P2, I want to display the value of X. So for that, what you will do is value printed using pointer is, instead of single star, we'll be using double star. So double star P2. It means P2 has address of P1 and P1 has address of X. So using double star, I'll get the value 12. If you want to find out what address is stored in P2, if you want to display that, then simply write P2. So P2 will have the address of P1. So P1 has this 96. So P2 will also have 96, since pointer 2 is pointing to another pointer, that is P1, and the address of P1 is stored in P2 is again stored at some particular memory address. It itself has its own memory location. So if you want to display the address of P2, simply write ampersand of P2. So 92 is the address of P2. So this is the way you can work with single pointers and double pointers and get a specific value using stars, double star or ampersand. Now the next is arithmetic and logical operations on pointers. How to perform arithmetic and logical operations on pointers. So in this, you cannot use all the arithmetic and logical operators on pointers. There are some limitations that which arithmetic operators you can use in pointers and which you cannot use in pointers. The first one is you can use increment and decrement operators on pointers. That is, I have a pointer P, you can use P plus plus, P minus minus, either in postfix or prefix notation. Now what would be the output if you use this increment decrement operators on pointers? Say for example, in P I have the address of 1000. When I do P plus plus means it will not be incremented by 1, but it will be incremented by 2 if it's an integer pointer, because integer occupies 2 bytes. Next value of P would be 1002 after incrementation. But if P is a float pointer, then after incrementing I'll get P equal to 1004 because float occupies 4 bytes. So the incrementation of pointer would by 4 bytes, that is 1004. P plus plus and P minus minus is not incrementing the value of the pointer by 1, but it would be incremented as per the type of the pointer. If it's an integer pointer, it will be incremented by 2. If it is a float pointer, it would be incremented by 4. Similarly, we can add or subtract integer number with the pointer. You cannot use a float, but you can use an integer number that can be added or subtracted from a pointer. Say for example, that is, I want to add 5 to the pointer P, or I want to subtract 4 from the pointer P. Let's understand what would be the output here in this case. Say for example, I have P plus 5. I want to do P plus 5. That initial value of P is 1000. When I want to do incrementing it with 5, means it would not be 1005, but the incrementing would be depending on the data type of that particular pointer. Say if it's an integer pointer, then 5 will be multiplied by 2 bytes because integer occupies 2 bytes. So the value of the pointer after incrementing it by 5 will get 1010 address. If I do the same thing, that is P plus 5, but if P is a float pointer, then 5 will be multiplied by 4, that is 20, and this 20 would be added with the initial address of P, that is 1000. So the new address that I would get is 1020. Okay, so this was about adding an integer with a pointer. Now similarly, we can go for subtracting an integer from a pointer. Say I have P is equal to 1000, I want to subtract minus 4. So the subtraction would be the same. If it's an integer pointer, we need to multiply 4 by 2 bytes. So 1000 minus 8, the new address that the pointer will have will be 992. Similarly, if P is a float pointer, then in that case, it would be 1000 minus 4 into 4 bytes of float. So that would be 984 address. Clear? When I do P plus 5, it would not be 1005, but it all depends upon the type of the pointer we have. Next valid operation for pointer is that two pointers can be subtracted from one another only if it is pointing to the same array. So you cannot add two pointers, but you can subtract one pointer from another, but the condition is that it should point to a same array. Say for example, I have an array A whose size is 10 and I have two pointers P1 and P2. P1 is pointing to the third location of an array, that is index is 2m, and I'm storing the address of a of 2 inside p1, and I'm storing the address of a of 5 inside of a p2. Means p1 and p2 are pointing to the same array but at different location of that particular array. This is the third value and this is the sixth value of an array. Say this is a memory layout. I have 6 values inside the arrays whose index starts with 0, 1, 2, 3, 4 and so on. These are the memory addresses. It's an integer pointer, so a of 0 is stored at 1000, a of 1 is stored at 2 and so on. So when I say P1 is address of A2, means P1 is pointing to A of 2. When I say P2 is equal to ampersand of A5, means P2 is pointing to A of 5. Now if I want to do subtraction operators on these two pointers P1 and P2, how I'll write this? P1 minus P2. P1 minus P2. What is P1? 1004 minus 1010. The difference here would not be equal to 6, but it would be, since it's an integer pointer, it will tell me the difference of the values between a of 2 and a of 5. So that is, the difference is minus 3. You can say this index is subtracted by this index. So 2 minus 5, that is minus 3. Similarly, if I reverse it, if I write P2 minus P1, what is P2? 1010 minus P1, that is 10004. So normally the difference is 6, but again you will not get 6, but you will get 3. It is 5 minus 2, which is equal to 3. So this is the way you get output of pointers when you do perform any arithmetic operations on it. Also, pointer variable can be used for in all the logical operators, like in this fashion. If I write P1 greater than P2, so if the address of P1 is greater than P2, in our case, say for example, P1 is 1004 and P2 is 1010. So when I write P1 greater than P2, I'll get false. So you can perform any of the logical operators on the pointers and accordingly you will get the output as true or false. Now let's see what are the invalid operations. Which operations you cannot perform on pointers. So you cannot perform addition of two pointers. You can perform subtraction on two pointers provided it points to a same array, but you cannot perform addition on two pointers. That is, you cannot write P1 plus P2 if P1 and P2 are pointers. Why? Because say for example, P1 is having the address of 1000 and P2 is having the address of 3000. So when I add, I'll get 4000. It may happen that this address does not exist in your memory. It may happen that it may go outside memory limit. So addition of two pointers is not available. Possible. Similarly, you cannot perform multiplication and division operations on pointers. That is, I have a two pointers, I cannot multiply it. If I do multiply it, what type of output is I'll get is 1000 multiplied by 3000, that is 3 and 6 zeros. It may also happen that this may be outside the memory limit. So this becomes an invalid operation. Similarly, you cannot divide one pointer by another pointer because if you do so, say for example, if I divide 1000 by 3000, I'll get 0.3. Memory address are never floating point values. They are always hexadecimal or you can say integer values. Okay, so these are the operations on pointers which you cannot perform. So this was all for today. We have seen two topics today. One is pointer to an pointer and another is different types of valid and invalid arithmetic operations on pointers, and we have seen the logical operators that you can perform on pointers. That's all for today. Goodbye. Thank you.